Hi dears, greetings to all. How are you? I hope you all in safe and security zone in your home. In this crucial time, we are following the online classes in all the schools. But while attending the online live class, some concepts we may left after completion of the class. To continue with the same concept, to keep on touch, we need some other assistance. For that case only, we are providing the physics videos for your convenience through this channel. So friends, if you are first time watching our channel, please kindly subscribe our channel, and after completion of video, if you are satisfying with it, you like the video and share it with your friends so that they can also benefited by using this video. Okay, and after subscription only you can get all the notifications when we are uploading the videos in this channel. Okay, right. I wish you all. First, in this video, 11th part of electrostatics, what is the topic we are going to discuss? In this video, we are going to discuss about electric field due to infinite plane charged sheet. Okay. In general, we know the formula for the electric field due to the point charge. And also we have discussed the electric field due to the electric dipole along its axial line and also the equatorial line. Okay. Now, here we are going to derive the electric field in different manner. By using the Gauss law, how can we find out the electric field due to the plane sheet of surface charge density? Here we are not considering about any charged wire or conductor or the point charge. We are having the plane sheet of uniform surface charge density sigma. Okay, right. Then we are going to apply Gauss law and the electric flux. Okay, only these three things. One is electric flux formula, and another one is Gauss law, third one is the net charge. If you remember these three things, definitely you will feel very easy about this topic. Even 4 applications of Gauss law, you may feel very easy. Okay, to making easy or to making hard, everything in our hands only. It is not in others' hands. Others means not teachers or tutors or anyone. Everything is in your hands only. Okay, so that in our channel we are providing each and every topic in easy manner, how you can understand the concept easily. And one more thing, specialization in our channel is nothing but from the basic for all the derivation I have given, even for derivation or integration or simplification, everything is given step by step in our channel. Okay, so kindly utilize this chance. Don't forget to watch all the videos, and don't forget to share this link to your friends also. Before that, you have to subscribe our channel. Then you will get all the notifications while uploading the videos. Right. Now, let us move to the topic. What is the topic? Electric field due to infinite plane sheet or charged plane sheet using Gauss law. Okay, right. If you are having any doubt, you can text me in this following mail ID or pchamiphysics@gmail.com. Okay, I will solve your problems. And if you want any PDF, you can send the mail. I will reply to you. Okay, friends. Now we can move to the topic. What is the topic? Electric field due to the charged infinite plane sheet. In this case, one different thing we have to remember, that is nothing but surface charge density. Okay, in the previous case A linear charge density we have discussed. A linear charge density is given by lambda is equal to Q by L. Here, what is the different thing? That is nothing but surface charge density. That is sigma is equal to Q by A. Why? Because here we are not considering about any particular length. Okay, there is no linear conductor is taken. Only the plane sheet of particular surface we are considering. That's why the surface charge density is given by the formula sigma is equal to Q by A. Because in the beginning of the video I told clearly there are three formula we have to remember. What are the three formula? One is flux, electric field, electric flux. Electric flux pi E is equal to closed integral E dot ds cos theta. In this formula, what are the things we have to calculate? What about electric field? That is we are going to calculate. So we need not to worry about that. ds, what is ds? Surface area. That we have to remember which Gaussian surface is going to be taken, what is its geometrical shape and size. Then what is the third one? Third one is nothing but cos theta. What is cos theta? It is the cosine of the angle between the electric field and the area vector. That is nothing but the cosine of the angle between the electric field and area vector. That is nothing but dA. What is area vector? The normal drawn to the particular surface what we are considering, or the perpendicular line drawn to the surface what we are considering. That is known as area vector. Okay, then one mark already I have told you. Angle between area and area vector is equal to always 90 degree. What is angle between area and area vector? Area is nothing but plane surface. Area vector is nothing but perpendicular line. So what is the perpendicular line? What is the angle it will make? It will 90 degree. That's why I told in two videos before, I told clearly the angle between area and area vector is equal to 90 degree. Right. Now in this first formula, we have to calculate the value of cos theta and we have to find out the value of ds. Then what is the next formula? Next formula is nothing but Gauss law. Gauss law is equal to what? Q net by epsilon naught. Okay, so in this case, what is the quantity we have to calculate? Q net. So Q net is given by the formula surface charge density. That is given by sigma is equal to Q by A. So Q is equal to what? Sigma into A. So we can calculate the net charge. Epsilon naught is permittivity of free space. It is a constant value which has the magnitude 8.854 into 10 to the power minus 12 coulomb square per Newton per meter square. That's all. If you know these three formula, you will need not to worry about the derivation of electric field due to the plane sheet of charge. Now we can see one by one. Okay, right. So in this concept, what is the first sentence I have given? Consider the infinitely plane sheet of surface charge density sigma, that is equal to sigma is equal to Q naught by A. Why we are using this concept? To find out the net charge. In Gauss law, we have the formula Q by epsilon naught. To find out the charge value Q, we are considering this concept. Okay. So infinitely plane sheet of surface charge density sigma, which is given by Q naught by A. Now, to find out the electric field, we are considering there are 2 points on either side of this plane sheet. Okay. Now, in this diagram, you can see clearly to find out the electric field, we are taking the 2 area of cross section on either sides. Then one more, we are taking the curved part of the cylinder. We are taking one more area. These 3 surfaces, there are P and P dash. Then one more is nothing but the curved part. These 3 Gaussian surface, they will have the electric field or not. To find out the electric field, we should have the electric flux. So first of all, we have to find out the electric flux value. You have to find out the electric flux value. Then one more thing you have to remember, from this center at the point P dash also it is at the same distance of R. This is the one-dimensional diagram, so we cannot show clearly. So in the textbook you can see that in right side there is large length, in left side less length, not like that. Both the point P and P dash, they are having the same length R from the infinite plane sheet. Now we are going to calculate what is the electric flux at the point P and at the point P dash. And also we are going to calculate the electric flux at the curved part of this imaginary surface or Gaussian surface. Okay, so from this diagram you can understand clearly, if you are consider the point P, what about the direction of electric field? Since this plane sheet it has the surface charge density positive, the electric field it will act directly outwards. Are you clear? It will act directly outwards. Right. Now, in this surface, if we are consider this Gaussian surface, this imaginary surface, here also the electric field it will act outwards. Now, the area of cross section considering is nothing but what? This is the area of cross section. So, in this area of cross section, we are taking, this is the direction of electric field. Now, if we draw the normal line to this surface, in which direction we will draw? It is also parallel to each other. Now, what is the angle between electric field? Now, this is known as electric field direction. Red color represents normal line. What is the angle between them? Since they are parallel to each other, we know that theta value is equal to 0. Okay, are you clear? Right. What about the cos 0 value is equal to 1? Now we can come to the left hand side. So in this surface also, if we consider the surface, what about the direction of electric field and normal drawn to the surface? Okay, what is the direction of electric field? It will act along this direction. What about the direction of normal line? It is also parallel. So what about the theta between E and D is here? Theta is equal to what? 0 degree. So cos 0 is equal to what? 1. Okay, right. So we can conclude that at the point P and P dash, the flux will be there. What is the flux value? Flux value is given by pi is equal to integral E dot ds cos theta. Here at the both the ends P and P dash, theta value is equal to 0. So cos 0 is equal to what? 1. Cos 0 is equal to 1 means this term will be considered as 1. What will be the remaining? Remaining is given by pi is equal to integral closed integral E dot ds. Here also closed integral E dot ds. Then E we are going to calculate. So we can take E outside. So integral ds is equal to what? Flux. Are you clear? So this is the thing you have to remember. If you are very clear in these three formula, you will not free any difficulties in this topic. Okay? Alright. So only in these 2 points electric flux will be there. So we can imagine that electric field also will be there at both ends. Now we can come to the third part. What is the third part? Here we are taking the surface area, curved part. So in this curved part, I am drawing the curved part separately. Now we consider this is the curved part. Okay. So in this curved part, we know clear the direction of electric field and direction of normal. This is the direction of electric field. Now this is the direction of normal. What about the angle between them? Theta is equal to what? Theta is equal to 90 degree. Where at this third surface, curved part of this surface. If theta value is equal to 90 means, what is the value of cos 90? Cos 90 is equal to what? 0. So what will be the flux? Flux is given by integral E dot ds cos 90 is equal to 0. So anything into 0 is equal to 0. So at this curved part, we know clearly the electric flux value, the pi is equal to 0. If there is no flux means, what about the electric field? Electric field also will be equal to 0. Okay, if you understand the picture clearly, then you can derive all the equations in easy manner. Okay, right, the same thing I have given here by applying the Gauss law. Then before that I have explained the description where we are taking the point that P and P dash are the 2 points taken either sides at a distance of r from the plane sheet. Since the plane sheet is infinitely charged, electric field will be the same at all the points, equal distance from the plane sheets, and it acts radially outwards. That means we are considering the 2 points P and P dash on either side of the sheet, so that the electric field also will be same at the points P and P dash, since they are having at the same distance. Okay, then the Gaussian surface A with the length of 2r from the plane sheet is chosen. So 2r chosen means we are choosing the surface on either sides. From the right hand side we are considering at a distance of r, and from the left hand side we are considering the point P dash, it is also at a distance of r. So the total distance they have given, it is equal to 2r. Okay, right. Now what is the total flux? The total flux value in the vector form, it will be given by pi E is equal to closed integral E dot dA. Okay, right. Now by applying the Gauss law, from this equation we can write pi is equal to q by epsilon naught. This is from the Gauss law. That is I have given here. Are you clear? Q naught by epsilon naught is equal to, there are 3 parts we are taking. One is curved part and P right hand side, P dash left hand side. Okay, already we have taken this diagram now. So this is nothing but curved part. So this is curved part P right hand side and P dash on left hand side. We are going to find out the total flux due to the Gaussian surface. So in this Gaussian surface, 2 ends we are taking and 1 curved part. Okay, that is represented here. The total flux is equal to q net by epsilon naught is equal to integral E dot dA curved part at the right hand side, integral E dot dA at left hand side E dot dA. Okay, right. Just now we have discussed at the curved part the flux value which is equal to 0. What about the right hand side? Flux value will be there. Left hand side flux will be there. That is explained here. I wrote here, for the curved surface, the electric field is perpendicular to the area element. So that theta value is equal to 90 degree, cos 90 is equal to 0. So anything into 0 is equal to 0. So flux value will be equal to 0 at the curved part. Are you clear? Right. Now, what about the electric field? Electric field also will be equal to 0. It is explained here. Since the angle between the E and the A is 90 degree, the flux will be vanished. Vanished means it will be completed. It will be 0. Okay. And hence the electric field also 0. If there is no flux means field also will be equal to 0. And for the cross-sectional area at the points P and P dash, electric field will be parallel to the surface. Parallel to the surface means parallel to the area element. So that what is the angle? Angle is equal to 0. Cosine of the angle value is 0. So cos 0 is equal to what? 1. So that the total flux which is given by pi is equal to integral E dot ds cos 0 at the point P. That is, this is for right hand side, and E dot ds into cos 0, this is for left hand side. So this is, this is right hand side, this is left hand side. Then the next step I have written. So only at the points P and P dash it can contribute the flux value. Are you clear? Right. Then we can derive the equation. The total flux is equal to pi E is given by integral E dot dA at the point P and integral E dot dA at the point P dash. Okay. So in both the cases, electric field which is the constant that we are going to calculate, we are going to derive. So it cannot be integrated, so it can be taken out from the integral part. Okay, so inside the integral, which is there, dA. dA means the area of cross section. Already we found the plane sheet, the infinite plane sheet. From the infinite plane sheet, we are considering the symmetric property, that is cylindrical shape. We are considering it has the area of the cross section A. That's why integral dA can be given by A. Are you clear or not? So that here we have taken E is outside and integral dA. Integral dA is equal to what? A. Already we have defined the imaginary surface of cross-sectional area. It has been defined. That's why we can write EA plus EA is equal to pi E. So by adding this, we can write 2EA. Okay, right. Now, by applying the Gauss law, the total flux is given by net flux is equal to net charge by epsilon naught. Now we are comparing the equation number 2 and 3. Okay, for pi net, okay, a total flux, we are going to use the value of q net by epsilon naught. That is given in the fourth equation. You can see this. Q naught by epsilon naught is equal to 2EA. Okay, right. What is Q? Q is nothing but the total charge. It can be found from the surface charge density formula. Surface charge density is equal to Q by A. So Q can be given by sigma into A by the cross multiplication. So that we are substituting sigma is equal to, Q net is equal to sigma into A. Now we are going to use this value Q net in equation number, suppose we are taking this equation number 5. This equation number 5, which is going to be substituted in the equation number 4 instead of Q net. Okay, right. So the fourth equation, it can be derived as sigma A by epsilon. What is sigma A? Sigma A is equal to what? Q net. Q net is equal to sigma A. Okay, is equal to 2E into A. Then A is common on both sides. A is common on both sides. So they will be cancelled each other. So what will be in left hand side? In left hand side, it will be sigma by epsilon naught is equal to 2 into E. Now we are going to calculate the value of E alone. That's why the 2, it can be comes to the denominator. Finally, we can get the equation E is equal to sigma by 2 epsilon naught. This is known as the electric field produced by the infinite plane sheet of charge. Okay, then in vector form, we can write E vector is equal to sigma by 2 epsilon naught into n cap. Only simple thing, here we are representing vector form, and right hand side we are multiplying with unit vector, where n cap is nothing but unit vector. Okay, what are the conclusion can we give from this point? In this case, we can write the vector form. In the vector form, n cap represents the outward unit vector normal to the plane. Why? Because the surface, it has the positive surface charge density, so that definitely the electric field, it will act outwards. Okay, then in the second point, we can see that the electric field due to the infinite plane sheet charge depends on the surface charge density only and independent of the distance. How can we understand this concept? Why? Because E is given by the formula. What is the formula we are writing? E is equal to sigma by 2 epsilon naught. So 2 is what? It is a numerical constant, so we need not to consider about that. So E is directly proportional to surface charge density. In denominator or numerator, there is no distance is represented, so that in the next part of the second point, they have given us it is independent of the distance r. This is important, one more question, second point. Okay, right. What is in the third point? It is common. Okay, so this will be followed in the next case also. If the surface charge density is greater than 0, the electric field at any point P, it is outward perpendicular to the plane. Suppose the surface charge density is less than 0, minus 1, minus 2, minus 3 like that, then the electric field at any point P is inward perpendicular. That is nothing but it will act inwards, which is perpendicular to the surface of the plane sheet. Are you clear? Right. When we look at these 2 points, we have to remember one thing. In the previous case we have discussed, if the lambda value, what is meant by lambda? Lambda is equal to linear charge density. So if the linear charge density lambda is greater than 0, electric field will be outwards. If lambda is less than 0, linear charge density is less than 0, electric field will be inwards. Okay, here surface charge density we are considering, so that the surface charge density, if it has the value greater than 0, plus 1, plus 2, plus 3, plus 4, 5, 6 like that, okay, then the electric field will be directly outwards. Suppose if the surface charge density is less than 0, minus 1, minus 2, minus 3 up to n, then the electric field, it will be directly inwards. These are the 2 things we have to remember even in the infinite long state conductor and also plane sheet of charge. This is very, very important. Charge density is greater than 0, field will be outwards. This is a simple thing, you have to keep it in your mind. If the charge density is less than 0, field will be inwards. Right. Now let us move to the next topic. What is the next topic? Finally, it is given by final point. For finite plane charged sheet, it is approximately true only the middle region of the plane. So it is also approximately, it is not accurate. Okay. So dear students, from this topic also we can expect 3 mark question or even 1 mark question. Okay. Right. So once again, you have to just practice this question with a step by step. Then finally, you will get easy idea how we can derive the equation for the electric field due to the infinite plane sheet of charge. Okay. If you have any doubt, you can send your doubts through email ID. It is given in all the pages, even the first page. The cover page also, I have mentioned the mail ID. If you want, you can send the question. I will try to clear it. Okay. Okay, friends. I hope you all enjoyed this video. Please subscribe this channel and share this link to your friends also. Okay. Thank you. Thanks for watching.